ng'ewagiddwa Maryland High School erisangibwa Entebbe. Ssomero ly'abawala n'abalenzi tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuukira ddala ku siniya ey'omukaaga nga lisangibwa mu kifo ekiweweevu obulungi. Tulina ebisuula eby'omulembe, science laboratory ssaako ne computer lab wamu ne.
She gives you her number, but your pen didn't work and the bus is gone. Get a pen you can rely on. Big Crystal, the long-lasting pen with perfect ink flow.
Wamu ne.
Green Hill Academy has high standards of learning and the teachers are very good. They give you a sense of belonging.
Green Hill has helped me to discover my talent.
The environment is good.
Encouraged us children to be excellent.
Wamune.
Kids Kingdom Kindergarten and Daycare. Somero ly'abaana bato. Omuzadde leeta omwana ogenda okola ebibyo. Ebyokuzannyisa by'abaana byonna mu nsi tubirina. Ate nga abaana we bazannyira wagazi nnyo. Jjukira security enka. Amasomero gonna gali mu kikomera. Abasomesa be tulina bakugu mu baana. Abaana tubaliisa bulungi nnyo munnange. Tulina main campus e Buddo Naggalabi nga bwakayisa Buddo Junior.
Yes, good morning, ladies and gentlemen. So I welcome you for this lesson on BBS final. So we are going to continue with our mathematics. So just that you get ready with your big pen and your book as we continue with our trigonometry as we have been doing the previous weeks. So let's start with a short prayer, then we go to our lesson. Lord, we thank you for life you have given to us. We thank you for your provision and everything that you have provided unto us. As you're going to have this lesson, we call upon your Spirit to come and guide us. That as I'm going to teach, they understand whatever I'm going to teach them, and also guide me as I'm teaching. I pray all that, believing and trusting in Jesus Christ, mighty name, amen. So we are going to continue with our trigonometry. So this is a very sensitive topic, and I believe how I've been handling it, most of you are on track and you are understanding what we are doing. So still I continue to appreciate those who are following. Most of you, I'm getting feedback. And I think nowadays you're only appreciating what we are doing. I think there are a few questions. Most of you have concerns on topics that you're not handling. But for the topic we are doing, I think only you are just saying, thank you, the topic is now fine. That's what I'm getting for most of you. So let us continue with our trigonometry. And we are looking at the angles of elevation. And last time I left here when we have done some few examples. So we are going to continue with the angles of elevation and the angle of elevation, and I had explained how we do it, understand how you first look at these numbers. They are still easy, like the things we have been doing before. We said what you need here is mainly interpret the question, because some of us we do fear word problems, but word problems still there's nothing much that we are going to see. Only what you have to understand is that interpret the question clearly, then draw a diagram. After that, go back and use the trig functions or the trigonometrical functions, as we have been seeing that the soccer tower. Use them. Everything will be okay. So last time I worked out two examples for you. And again, make sure that you follow everything. Whatever I'm talking about here is something that we are going to use. I told you last time about the angles, that as you move, as the distance from the point that you are maybe looking at the angle of elevation and depression. We talked about that you look at the distance. If I move a little bit far, the angle decreases. You're going to see some questions also addressing that. So let us do some other examples. And today I'm completing the angles of elevation. As the next time we do the angles of depression, then after that we go to something else. So I believe we are soon completing the trigonometry. So let us look at the questions. Last time, the questions that we are doing, and they are going to cast these questions for you. I think you can go to another number. Last time we did some numbers. So I'm having out of questions I've organized about angles of elevation. So we are going to try some few examples together. The other questions are going to be left to you as exercise. So you please, you copy these questions down. The answers are also there. I told you my secretary is now back, so she typed these questions. And also she's good at mathematics. So she did some of the numbers. The answers are there. Also I tried some. So we'll be doing, after trying the number out, mark yourself. Because most of you have been having concerns that we are doing these numbers, we are trying out, but we have nobody to mark us, to guide us. So that's why we are putting the answers there for you. So let us look at these questions. I know my producer is going to put these questions for you. You can look at those questions there. So last time, we worked out a number, like number 1, we use a number like this. I'm not going to do it. Number 1, you can do it now. Last time, these questions were not ready, but number 1, we can do it. So number 1, I'm leaving it out because we did an example which is exactly similar to number 1. When you say that, when you work out that number, your angle will be that, our angle of elevation will be 51.34 degrees. So please try out the number. Draw a diagram, interpret the question, see how you come up with that answer. And again, we have that number 2 is saying Kiara is looking at the top of a tree if she's 3 meters tall and the angle of elevation to the tree top is 45 degrees. Find the height of the tree if Kiara is 15 meters away from the tree. Now, see that number, I'm leaving it out because last time I worked out a similar number like that. It was a similar number. We had Okello, yeah, it was Okello who was looking at the top of a building. So we had the angle of elevation and also we looked at the height of Okello. So that if you are getting the height of the building, don't forget, you have to add, you have to look at what you are going to get plus the height of Kiara in this case. So please, that number, also number 2, those who are here in the previous lesson, I believe it's very okay for us. And we don't have a lot of time. We want to do some other number which is somehow different from that, so that we can be able to do all the numbers concerning the angles of elevation, and also we'll be seeing the angles of depression. So let us look at number 3. So number 1 and 2, I'm leaving them out because I did exactly the same examples last time. So those I'm leaving them out for you to do. And then you are looking at number 2, the answer is given there as 18 meters. So please work out and see that you get that answer on that number, which is having Kiara looking at the top of a tree. So please work it out and you see that you get the same answer, 18 meters. Then also we have number 3 saying a ladder 16 meters long leans against a wall and makes an angle of 5 degrees. So I'm going to try that number, and also I will do other numbers, then we get done with the angles of elevation. So please write down the question. Write down the question clearly as we see how we are going to do it. So please copy down the question. Copy down the question. So I'm doing number 3, number 1 and 2. You will try them out. They are similar to what you have been doing. So let us look at number 3. Write down number 3. Even also you copy the other previous questions. Also you write the answers that when you are trying out, so make sure that you get the same answers there. You get the same answers. So we are saying that these word problems, most of us, we just fear because we see words, but there's nothing hard about these angles of elevation and depressions. And there are very many ways we can set them to test for different concepts. So please, when you come across these numbers, don't fear them. Just be firm and you try, you interpret the question and say that these numbers, it's better every time you are doing them. Draw a diagram because it's going to be very hard for you to do this number without a diagram. So always draw the diagram, have a simple illustration for you there that you are guided. So doing it will be easier. So we have that number 3, so I'm trying to write the question, I'm trying to interpret the question. They're saying that a ladder which is 16 meters long leans against a wall and makes an angle of 5 degrees with the wall. So I'm trying to draw a diagram here. Yeah, so this is something that all of us have ever seen or have ever tried out. So you're having our ladder. In this case, this is my ladder here. This is my ladder, and I say that it is 16 centimeters long. And last time I told that you have to be very careful. Sometimes they can mix up the units. They can give you maybe one in meter, other in centimeter. So you have to be able to convert. So be very careful. Don't get too excited. Not since that the units are the same. In case you are given maybe 2 different dimensions and see, am I supposed to convert or they are okay, then you continue. So this is our ladder in this case, is 16 centimeters. Now it is leaning on the wall like how you are seeing it. So we have ever seen this, like I want to climb but maybe at the top of the building and so on. I have to put this ladder, I have to make it to lean on the wall like the way it is happening, or like the one we're illustrating it here. And they are saying that this is our diagram. I've finished that. So I've already got the diagram. So you see in this case, you have to draw it on your own. Previously, I was giving you numbers to use the trigonometrical function where I've drawn for you the triangle and so on. But in this case, you have to draw it on your own. And now this means that this angle here is 90, where this wall is meeting with the ground. So this is the ground. This is the ground. Yeah, that's what we have. Now they are telling us that how high up the wall does the ladder reach. So now if you look at this one, how high up the wall does the ladder reach? That means that they want this. They want the height. So that means that they want us to get this distance from here, the height from here, from the ground, up to this point where the ladder reaches. Here. So it means that this wall is still continuing. Actually, even I can do like this. It means that the ladder was not stopping at the top, at exactly where the wall stops. But they want me to find from this point, from the ground up to this point where the ladder is stopping. That's what they want. So you come back to our diagram. You have to identify which one is the hypotenuse, which one is the opposite, which one is the adjacent. So if you look at this, that our hypotenuse is this, which is opposite, the right angle. So this is going to be my hypotenuse. I can note it by capital H. And again, I have this. So that if you look at the angle, now the angle here is between two sides, the hypotenuse and the adjacent. It means that this side will be my adjacent. Because most students that they fail these numbers because they fail to identify the adjacent and maybe the opposite. That means that what remains here will be my opposite. That is that. Now what they want me to find is the adjacent. So I have my hypotenuse, I have the angle, I can get the adjacent. So you go back to our soccer tower. We use the soccer tower since you want to get this height, how far. I can call it anything. Maybe I can say this is x. I can call it x. So we come here and said, I have to go back and use soccer tower. Now from soccer tower, we have to be very careful. We have the hypotenuse. So ask yourself, what am I going to use here? And h is missing. So ask yourself, what am I going to use? Since we are supposed to get the adjacent, you ask yourself, what am I going to use? So you have the hypotenuse, I'm going to use the cos. So some people, they fail because they don't know how to use the trig function. So please check and see what you're having and you see what you're going to use. I have hypotenuse and also I want to get the adjacent. In this case, I have adjacent, I have hypotenuse. It's going to be in the cos. So I come back here and say that from what I know is that cos of theta or any angle is equal to adjacent out of the hypotenuse, like that. Now for this case, I have my angle as 33 degrees. I can say cos of 33 degrees is going to be equal to adjacent, which I'm looking for. I've called it x. Then out of the hypotenuse, which is 16. Yeah, so this is my cos 33 degrees equals to x out of 16. So, but I need to get x. So I'm just going to, I can multiply by 6 on both sides, by 16, yeah, by 16 this side, by 16 this side. It means that when I multiply by 16, it will cancel out on this side. So I'll be getting my x. My x becomes 16 cos of 33 degrees. And see, it does no harm if you first place cos 33 degrees, then 16 times 16, see, it's okay. So this becomes my x. And so that this type of questions, or if you're handling this topic, you need to have your calculator, please. So now you get your calculator, you are going to place 16 cos 33 degrees. And so you say that this 16 does not multiply the angle. You're just going to place, you can place the way it is on a calculator. Say 16 cos 33 degrees. Also, you can first place cos 33 degrees, then you get the answer, then times 16. So most of us fail because don't know how to use the calculators. That's why sometimes the times when I organize, those ones I think mainly because senior 5, even sometimes senior 3, I organize them out, how we use calculator, senior 2, because some students, they fail these numbers just because of the calculator. I don't know how to use the calculator. So we are getting our answer, and I'm getting you on my calculator as x is 13.4. So please don't overround off. 0.4187. So I'm getting that. You can use 4 decimal places, you can use 3, but don't overround off. You can use 3 decimal places, or minimum you can use 2 decimal places. But some of us even want to go up to 1 decimal place. Some of us we don't want to have any decimal place there. So please don't overround off. You can write at least 2 decimal places. So we're having our answer, x is 13.4187. You can say 419 centimeters. So that means that the height, how far, we are saying that question of part A. They're saying how high up the wall does the ladder reach. So this is going to be our answer. So the height is going to be 13.4187 or 19. And if we compare with what we have there, that's the answer that we have. We have the answer 13.419. So that is what we have also got here as our answer. So you say the distance, let the height be x, then we have got our x as 13.419. Even you can come back and make a conclusion that therefore, maybe the ladder reaches 13.419 centimeters above the ground on the wall. Let us go to part B. That's our part A. So please you can write that solution down. You can put the solution down. So if you have a diagram, everything else will be okay. Just telling us part B, how far from the wall is the foot of the ladder. So I'm on number 3, part B. They're saying how far from the wall is the foot of the ladder. Now in this case, you have very many ways of doing that number. But since you have the adjacent, you have the hypotenuse. If you want, see, you can use the Pythagoras theorem. You can use it and see you get the answer right. If you still you want, you can go on and use the trigonometry, the trigonometrical functions. So in this part B, you can do it in 2 ways. So I'm saying 1, you can use the Pythagoras theorem. I know most of you even now you are done. So you can use the Pythagoras theorem. You get, because now what they want this one as our opposite, because they are saying how far from the wall is the foot of the ladder. They want you to get from here, from the wall and up to the ladder. That's what they want. So they want the opposite. I'm saying that you can use this right angle triangle. You can say this one, if you get opposite squared plus adjacent squared is going to give us 16 squared. You get this distance that you want. That one can work. So if I'm calling maybe someone to by, this distance by. So you can use Pythagoras theorem if you want. It's fine. Or if you don't want to use that, I can also use the trig function. What you want to get is opposite, and I have hypotenuse, I have adjacent. I can use tan, it's okay. I can use the sine still, it's okay. So let me use tan here. Let me use the sine since I want to use the other. So I can use sine, and as a sine 5 degrees is going to give me the opposite, which I'm looking for, and I'm calling it y out of the hypotenuse, which is 16. So I'll be getting my y to be 16 sine of 5 degrees. So I'm getting my y as 16, press this on the calc, 16 sine 5 degrees, we get 8.714. 8.714 centimeters. So this becomes that distance that they want, 8.7, this is the point here, 8.714. And I'm saying that if you want, you also try the Pythagoras theorem. Just because I want to do some other numbers for us, I won't do that, but I know some of you have already tried it. You are very bright students, some of you have already tried using Pythagoras theorem, you get the same answers. You can also use tan, you get the same answer. Yeah. So we put that down, then after we see that we go to another number. Put that down. So we have the other numbers there. Put that down, please. Now we have number 4. You can look at now number 4. So I'm going to leave it out for you to try. You know, we don't have a lot of time, and I want to do some good numbers. That's why I organize all those for you to. So if you look at those numbers, they're enough for you to be able to pass a number concerning the angle of elevation. So angle of elevation is when we are looking up. So we have that number 4, and I'm saying number 4, I'm leaving it out. So number 4 is saying that we are a vertical post casts a shadow of length 14 centimeters when the angle of elevation is 48 degrees. Find the height of the post above the ground. So that one, please just do a diagram. And when you're doing this number, you can compare it yourself. You can compare it yourself and you see how the shadow is. So this one you can, I believe you can do that one. You can do that. So we are going to go to number, so the answer is there, 15.54. Make sure you try it and you get the answer. We are going to do, number 5. Let us do this number 5 here. It's also a very nice question. Number 5 is saying that we have two students, A and B. Two students A and B stand on opposite sides of 100-meter tower. That one is a very good question. They're saying that A observes the angle of elevation of the top of the tower as 45, and B observes it as 30 degrees. So this is fine. So we can try that number. So what you need here is only the diagram. But please copy the question down. We are going to do that one also. So please, the good thing that now here in this case we are putting the answers for you. So try the numbers. And after trying out the numbers, the answers are right there with you. So you can always see that, check and see that your answer is corresponding to what we have given you. And I believe there are no mistakes there. So your answer must be what we have given you. So copy the question down. We are looking at number 5. So I'm saying I'm leaving out number 4, that we can try it out on our own. So what we need still is first of all the diagram. And I'm saying this pole is 100 meters. And we are having two observers. We have A, and also we have observer B. Now these two are observing the same thing. They are observing at the same point. They are observing the pole, or they are observing the tower, which is 100 meters tall. And they're telling us that observer A, the angle of elevation is 45 degrees, and observer B, it is at 5 degrees. So we have A at 45 degrees, then B 5 degrees. So I'm having this is 45 degrees, then this B is 5 degrees. So if you look at what I told you last time, it means that you can do that in your diagram if you want. But what I say that if the angle, the more you move closer to the point that you are looking at, the angle is going to be the angle will become big. It's going to become bigger. The angle is going to become bigger. As you move close to this point, the angle becomes bigger. And as you move very far, that means that if you were to use that thing I told you last time, that logic I told you, it means that this distance of B from this point is going to be bigger than this. Yeah, I'm just telling you that you should know that one also. So that means that if I have this one, this will be 30 degrees. Yeah, so we have that. Then they're asking me to, how far apart are the two students? That means they want me to get distance AB. Because we're having A from A up to this tower. Also we have from the tower up to distance B. Now we are saying how far apart. They want you to get distance from here up to B. So it means that I'm going to use the two triangles. So it means that this angle here still, this is a right angle triangle. And so even if you look at that triangle, so this will be right angle like this. This can say this is the foot of the tower. I can call it maybe O, like that. I can call the top here, I can call it maybe C. So it means what they want here, they want you to get the length AB, distance AB. And now we get this, that you first have to get AO. After getting AO, so you get OB, then you add the two distances. And looking at this, I'm going to first use this triangle. Use this triangle, AOC. Since I have the angle 45, I also have here 100 meters. I can get this. And look at this triangle AOC. This will be our adjacent. This will be my hypotenuse. And this will be my opposite. So when I come to triangle OCB, so this will be my hypotenuse. This one here still is going to be my opposite. And this will be my adjacent. So let us do this very fast. We get the distance AB, and we'll see if we can do another question. So I want us to do, we are doing some good numbers that you can find. When you find other numbers, you are able to pass them. That's why I'm trying to do some good numbers for you, some good examples for you. So let us look at triangle AOB. So looking at triangle, so first I'm using triangle which is A or C. So I want to get distance AO. AO. So I see AO is my adjacent, and you go back and use the soccer tower. It is guiding us everywhere. The soccer tower, it helps you to understand. But as you practice, also this will become part of you. So I'm using the triangle AOC, and I want to get the adjacent. I have the opposite. That means I'll go for tan. So I'll be having tan of 45 degrees. This will be equal to opposite, which I have as 100 meters or 100. Then out of, I can say this is going to be AO. This is length OO. Even you can put maybe X, Y, whatever you want. There's no problem. So you're having opposite of adjacent for tan. Then I want to get AO. I can say this is going to be, I can multiply by A on both sides. So I'll be having AO, length AO, tan 45 degrees. This will be equal to 100. So if I want to get AO, I have to divide by tan 45 on both sides. So I'll be having something like this. And tan 45, if you press on the curly, this will give you 1. So it means that I'll be having my AO as 100 meters. This will be my AO. And again, I go back and also I use triangle OCB. So you can still extract those triangles if you want, but I've explained very well how we are doing this. I'm using triangle OCB, this one here. If I use that triangle still, I want to get the same thing, I want to get the adjacent. So getting the adjacent, I have the opposite, I'm going to use tan. So you can say tan, in this case the angle is 30 degrees. It's going to be equal to opposite, which is 100, divided by the adjacent, which I'm looking for. You can say this is length OB. So I'll get my OB, length OB, tan 30 degrees, equals to 100. So I will say that if I want to get the OB, I will divide by tan 30. So I'll be having 100 divided by tan 30 degrees. Don't forget, please, for angles, we should be having the degrees there. Then again, after getting the distance, you put the units, put there. If centimeters, put centimeters. If you are having meters, put meters. So you go on your calculator, you press that, you're having 100, you divide by tan 30. So please, you must be having a calculator. Don't just try to use the head to work out this, use the calculator. And I'm getting 170, on the calculator I'm having 173.205 meters. This is what I'm getting there. Now what you do, you want us to get the distance, how far apart are the two students, how far. So what I'm going to do, I'm going to add the two distances. So I'll answer that question, I'm going to add AO, length AO plus length OB. So I'll be getting 100 plus 173. And please make sure you present the working. Don't hide. Some of us, we hide the working. Don't hide the working. Present everything there. Don't hide anything. So this will give us 273.205 meters. So it means that the two students A and B, or at A and B, are 273.205 meters apart. So that's what we are getting after adding the two distances. So that is our answer there. That is our answer. So please copy this working down. Then I want to say that I do another number for you. So angle variation, this is how we have to do it. Some of you are saying this was a very hard concept before we did it, but I believe now things are becoming better and better. So we're having that. That's our answer, 273.205 when you add the two distances. So we're having the two points A and B, or students at A and one at B. They are 273.205 meters apart. So that was our number 5. And please try these numbers. The good thing, the answers are there. Try the numbers out and so that you get the same answers. So when you go back to the questions, we have that number 6, and I believe number 6 we can read. It's talking about the angle of elevation of the top of a flag pole to piers, whose height is 1.7 meters, and standing at a distance of 6 meters from the pole on the level ground is 20 degrees. Find the height of the flag pole. So this number you can read. This number resembles the same number we did last time, and see it's the same thing as the number we have seen of Kiala. So this number, having piers, you can do that number, please. Number 6, you can try it out. And we're having our answer is 7.524 meters. So please try number 6 and see that you get the answer. What you only need that you draw a diagram which is right for the question and interpret it clearly. Because this person is looking at the flagpole and they're saying whose height. That means the height of the flagpole is 1.7 meters. So you can get whatever they want. You can get whatever they want there. No, it's piers. No, so piers 1.7 meters. That means that piers is having that height of 1.7 meters and starting a distance of that. So the distance of piers from the pole on the level ground is 16 meters. It means that if you have the angle of elevation and you're having this distance, so what you're going to use the distance of these piers from the pole. Okay, let's do it here. Why don't we do it? Let's do it very fast. So some of us, these are numbers that give us headache, but they are easy numbers. So what is number 6? And also this time is going to enable us also to do one more number. That angle of elevation will be done. And I believe when this is done, it shouldn't be a problem to you anymore. These are supposed to be numbers that you find in the exam, and you can clap the hands, you can stand up for a minute and you dance before you do the number. So there's no problem. Or even you can wave at your friend in the other corner, seeing that you are going to get some good marks here. So we are looking at number 6. Let me do it for you very, very fast. And you see that we can continue. So this piers is looking at a flag pole. So please copy the question. And if you're having a phone, you can just take a photo of that and then you copy it down later. So make sure that you copy even the answer, that even if you try out in your free time, you can still get the same answer, because now nobody is going to mark you there. But if you have the answer with you, you try it as many times as you can so that you get the same answer. So we are having, you just draw a diagram clearly. So we are having the pole. This is the flag pole. This is it. Maybe the flag is at the top here. We don't need to draw actual stuff. What we need is the mathematical diagram that can help us to work out some numbers. So I'm having the flag pole is this. Then we're having piers, whose height is 1.7 meters, starting a distance of that from the pole. So piers is here. Hey, I have some friend of mine called piers. So I don't know if this is what the secretary was meaning, but we have this. So this is my piers. You don't need to be a very good artist. Just draw whatever you draw to interpret, and then you move on. So this is my friend piers here. So yeah, piers is down there. Then the piers is having a height of 1.7 meters. So it means that piers, if you look at the height of piers from the ground here, so these numbers, they are not high. Only that you need to interpret. And most of us, we fail these numbers because of English. Not that we don't know the mathematics, but we fail to interpret the question. So piers is 1.7 meters is there. Then a distance of 6 meters from the pole on the level ground. So it means that this distance from from piers to the pole, this is 16 meters. And now they are saying that the angle of elevation is 20 degrees. Now, angle of elevation from piers here. So from piers is observing the top. So the angle of elevation. So please, when you are drawing those of yours, use the rulers. So angle of elevation here is going to be 20 degrees. So it means that we have something like this. Yeah, this is what I'm going to have. This is what I will be having. So this angle here is going to be 20. So piers is observing clearly here. observing. So angle of elevation is 20 degrees. Then I'm having the ground. This is the ground here. And this is 16 meters. But it means that if this is 16 meters down, even this distance also will be 16 meters. Also this will be 16 meters. So please do nice diagram. Since you have the rulers also with you, that will also be 16 meters. So now I get what they want. They want me to find the height of the flagpole. It means that I'm supposed to get this distance from here. I'll first get this distance from the flag up to the level of piers here. And after that, this height is similar, also is 1.7. That means that to get the height of the flagpole, I'm going to get this one from here up to this point of piers, and also I add the height of piers. That will give me the height of the flagpole. And I think we can do that. I'm just going to explain this because there's a number I want us to do, and time is not on our side. But here, if I'm looking at this one, it's going to be my hypotenuse. Then this is going to be, this is still 90 degrees. This is going to be my adjacent. It's going to be my opposite, like that. So what I have to do, I need to find the opposite. So since I have the adjacent and the angle, I need the opposite. I'll be using the tan. So I'll be using the tan to get that distance which I want. So I'm going to use the tan. Let us do it very fast. So from here up to here, I can call it maybe, I can say maybe this is distance x. So to get the height of the building, it will be x plus 1.7 meters, but I need to first get x. So I will come back here and say that tan of 20 degrees, since I'm having 20 degrees, it will be equal to opposite, which I'm looking for, and I'm calling it x, divided by the adjacent, which is 16. So I'll be getting my x will be equal to 16 tan 20 degrees. I go to my calculator, so please make sure that your calc has to be there with you. So I go to my calculator, I press 16 tan 20, 16 tan 20, and this is giving us 5. So we are getting x as 5.8 235 or 24 meters. So this is my x. But that's not what they want. Some students are going to stop there. But it's not what they want. They want me to get the height of the flagpole, or this flagpole. It means I have to go back and add plus the height of piers, which was 1.7. So height of flagpole here, height of the flagpole, this will be equal to x plus the height of piers, which is 1.7. And when I add my x, which was 5.87, so I'll be having 5.824 plus 1.7. So we add that, calculator, 5.824 plus 1.7, end up getting 7.524. So height of the flagpole is going to be 7.524 meters. So that is my height of the flagpole. Yeah, that's the height of the flagpole. So we are doing some good numbers here, that when you find such questions in the exam, there shouldn't be any problem to you. There shouldn't be problem to you. The numbers that you need to pass. So we are going to do one more number. What time can I ask you to do one more number, I believe. So number 6 is done. So let us look at number 7. So we have another number there. So please, after doing this, go back and try more other questions. Go and try more questions in the question bank. Try very many. So I'm just giving you this, but questions are so many. And I thought that if you have to pass mathematics, you need to practice. Right here now, the concept is good. I've done for you good numbers. So you just need to practice. So we're having those other numbers. We're having number 7 and also number 8. I was able to get for you these questions here. Now we look at number 7. Let me do for you number 7. Then the other number, you can be able to do it. So we're having that two trading centers A and B are 200 kilometers apart, 200 meters apart. The angle of elevation of the top of a hill from the trading centers A and B are 60 and 5 degrees respectively. Calculate the height of the hill. The trading centers are in part A, the same side of the hill. So please write the questions down. Write the questions down. So we're having that. So we're going to do number 7. We're having two trading centers, A and B. They are 200 meters apart. So please read the question clearly. Go step by step. And what you have understood, you try to illustrate. So what they are telling us that these trading centers in part, if they are on the same side of the hill, on the same side, and also they are telling us in part B when they are on different sides. That's what they want us to work out here. So see what you do. You are going to first read the question, then we see how we are going to get this. And please copy the question down. Some of you complain that we are somehow very fast sometimes, but the question is there. Please copy it down. And if you're having a phone, most of you are having phones, so please just capture that, and after you will copy it later in your book. You copy it later in your book. So please, we have those two trading centers. So for these things, don't struggle. Just try to understand the question. Try to illustrate what they are telling you when they are asking you. After that, you can be able to find whatever they are asking you to find. And please keep in mind that the soccer tower is going to be used, soccer tower, and you're going to see other things talked about, maybe the signs of those trig functions. You're going to see them later. But in this case, what we need, soccer tower, we are seeing how we are applying it to find the unknowns in case of angles or the distances required. Yeah, so we are having this diagram. I'm trying to illustrate that. So we are looking at there are two town centers, A and B. Two trading centers, A and B, they are 200 meters apart. Yeah, the angle of everything at the top of the hill. So we are focusing at the same point. Most of us will fail at this point. We have to focus at the same point. For example, they do it when one triangle, one is focusing here, let's not try it. They have to focus at the same point. Remember, this angle here is going to be 90. So these 2 points are 100 meters apart. And since they are giving us angles of elevation, that means that I'm going to have to be very careful. What is A, what is B? Sometimes you might be able to fail depending on how you are placing your trading center in this case. So we said that one of the angle for A, they're telling us angle for A is 60. Angle for B is 5 degrees. Last time I told that this person who is very close to this point, this angle will be bigger than this. So it means that the correct diagram should be that this has to be 60 degrees. Then this has to be 30 degrees. I talked about this last time. So if you come a little bit, if you come near here, the angle will become bigger. Move away from the point, the angle will become smaller. So this is A is 60, so it means this is going to be our A. And this is going to be our B. They are saying that these two are 100 meters apart, means that 200 meters, means that if you look at this distance from here, they are 200 meters apart themselves. So if you look at this point, we can consider point O. Then these ones are 200 meters, means that from A to B here, we have 200 meters. So please be very careful. The problem here is not mathematics. I've seen it very many times. The problem is English. How do you interpret the question? That is the problem. And that's why you have to be very careful when they are teaching us the English. Be very careful. Because even you see the same problems happen sometimes in A-level mathematics. People where we have to apply the English, interpret the questions, they fail. Read the mathematics is okay. So English becomes the problem. And some of these numbers, not like these word problems, try to imagine, have an imagination and see. You can try to draw a simple picture and see what they're talking about before you try to work out the number. Also, other thing is that before attempting, you can even interpret it in your own language, local language. If you're Muganda, if you are Msoga, if you are what, put in your local language and try to interpret the question clearly. So this is what we have. They want me to find the height. They want me to find the height of the hill. That means they want me to get this height from here. So this is from O up to this point. I can quote maybe point C. I want me to find distance OC. That's what I want me to find. So look at what we have. We have this triangle here, but we won't help us because we have the angle, we don't have this side. If you had this side, it would be okay. We have this bigger triangle, but still it won't help us because we have the angle, we don't have this distance here. So what we can do, we can look at, we can say maybe this distance is x. I can call this distance x. So maybe I can call this one to be y. So then we can do and see how we're going to do it. So I can first get this distance, x. Is it possible for me to get the x, this one here? Because these are 20 meters apart and they're on the same sides. So I can get this x. And after having x, I can get the height of the hill, which is y. So let us look at this. I'm having this angle here. Or even if I get BO, I can still get BO. If I get BO, still is going to help me to work out and get this side, which is y. So since we have an angle, they are all looking at the same top, the angle of elevation at different points. A is here, and B. So I look at when you come a little bit nearer, the angle becomes bigger. So 65 degrees. They are the same side of the hill. That's what we're having here. Capture the height of the hill. Yeah, that's what they want. So let us look at this 5 degrees. We can take this bigger triangle. You can take the bigger triangle. Then we look at this. So I'm looking at the bigger triangle. Oh, so these things are so interesting. So look at the bigger triangle using triangle BOC, the bigger one. So I'll be having a triangle which is like this. Yeah, so this is a very nice number. So I'm having this triangle which is B. So I'm having O. Also I'm having, so now this distance is 200 plus x meters. And I have this angle as 5 degrees. So I can use this one here. Because the height still is going to remain y. So I can use this. I can use this one. So if I'm using this, since I'm having these two sides, this is going to be the hypotenuse. So this is 90. This is going to be the adjacent. This is the opposite. I can use tan. So I can say tan 5 degrees is going to be equal to opposite, which is y, divided by 20 to 200 plus x. I have that. That's going to be my y. So still I can cross multiply if I want, and this will become 200 plus x into brackets. Don't forget the brackets there. Tan 30. This will be equal to y. So this can be my first equation, because in this case I have two unknowns. This can be my first equation. And again, I use the smaller triangle. I'm going to use also the smaller triangle. So please observe this carefully. These are some of the nice numbers that they are good to dissect here, and we enjoy them. So what matters must interpret. First interpret the question. After interpreting the question, everything else will be very okay. So I guide now, I look at the smaller triangle. So using the smaller triangle, which is OSC. So I'm using now a triangle OSC. I'll have a triangle which is like this. I have a triangle which is like this. So now we are doing some. So still we have, this is now x, this is 60 degrees. Yeah, this is y. That's what I will be having. So what I'm going to do, I'll be using the tan. So tan of 60 degrees, this will be equal to opposite, which will be still y. So I'll be having y out of x. So this will give me y as x tan 60 degrees. So I'm getting y equals x tan 60 degrees. But now we have the two equations. So I'm going to, our time is done, but we have the two equations. We have equation 1 and equation 2. So I'm going to solve two equations simultaneously. Even I can just substitute. I can use this equation 1, which is